Good morning. As newly promoted HIT coordinator, I've created a diabetes registry using a database which is to be used to give a snapshot of the patient's progress and help develop some further interventions for subsets of diabetic patients. The diabetes database right now is a pilot program and consists of only 20 patients. Right now, there are 4 users who will need access to the diabetes registry database, each with a different job function. To provide some background to the diabetes registry, in 2015, the percentage of mean adults aged 20 and above with diagnosed diabetes is about 10% statewide. This prevalence includes both type 1 and type 2, which have different causes, pancreatic insufficiency versus insulin resistance. While treatments may vary, the sequelae of both diseases are the same and include nerve, kidney, and cardiovascular damage related to the chronic high glucose. This registry is modeled after other existing registries, like the Diabetes Collaborative Registry, which allows a provider to track patient data across multidisciplinary providers with the goal of improving patient outcomes. The current structure of this database includes 7 tables. The demographic table is the main table, and all the other 6 are linked to this table in some way. There is the diagnosis and ethnicity table, as well as a table that captures patient assessment data, coronary health, microvascular, and glucose lab work. The demographic table includes the patient name, address, as well as the ethnicity and diabetes diagnosis. The ethnicity and diabetes diagnosis are foreign keys, which are linked to the so-called named tables that help maintain the integrity of these fields by requiring those entering the data to pick from a subgroup of diagnoses or ethnicity. It will make sure that any queries built upon these fields would not be subject to typos or incorrect data entry. All of the remaining tables are linked to the demographics table by the primary key, which is the unique patient ID number. Each table includes a different set of risk factors. When working with the data, one needs to create users to access the database and perform different tasks. But before this is done, one needs to understand some of the laws and regulations that cover personal health information, or PHI. The main federal law that covers the data that is collected in this Diabetes Health Registry database is HIPAA, or Health Insurance Portability and Accountability Act of 1996, as well as the security and privacy rules. The security rule requires that the data remains safe from unauthorized access, alteration, deletion, and transmission of the data, while the privacy rule means that the data is supposed to be kept private. This means that not everyone should have access to all of the data to view, and it should not be open to all of the users to make changes to the database. One of the best and easiest ways to remain compliant with HIPAA is to create individual user accounts that are password protected. Because each of the 4 current users have a unique function with the database, each person should have a different level of access. Part of remaining compliant to HIPAA is to make sure that access to personal health information is personalized to job function, with a person having access to the minimum amount of data needed in order to adequately perform their job function. By creating layers of access to personal health information, there's a lower risk of inadvertent or purposeful data breaches. With regards to the Diabetes Registry database, PHI includes patient name, demographic information, as well as individual test results or even appointment dates. As previously noted, there are currently 4 users. Hadley B is the administrator who should have access to all of the data in the database and should have no restrictions on the tasks that she can perform. Nick P is solely responsible for running backups. Graham B can enter and modify data in the tables, but not delete. Finally, there's Susan O, who is the primary nurse practitioner. Her role requires that she has access to only the data necessary to develop education and contact patients in order to improve patient outcomes. She will need access only to view certain aspects of a patient record, but will not be required to enter or change any patient data. Although it is possible in MySQL to create users with only these privileges, I have opted to create roles. As this project grows beyond the original 20 patients, it's likely there are going to be multiple people doing the same job function. By creating roles, it means that one can easily assign the same privileges to all performing the same job function. In addition, it is possible that as time goes by, some people will change their job function. For example, Graham B. may be promoted and become another primary nurse practitioner in charge of creating interventions. He will no longer need ability to add the data. However, he will need to view certain reports. Therefore, instead of individually adding privileges that can be inadvertently forgot to be dropped, the old role can be dropped and a new one assigned that contains only the privileges that that person requires. Finally, one can expand or tighten access to an entire class of people, for example, clerks, by using the roles instead of having to do it a la carte. The first role, as stated before, is the admin role, who should be able to access all of the table in the DB_reg, which is the diabetes registry, hence the asterisk, and she should have no restrictions on what the user can do. I created the user account for Hadley B, and as administrator of the database, I have assigned her this role, and therefore she will have all of the associated privileges for this database. The next role that I've created is for someone to perform backups. In general, it is good practice to create a separate user and user group to create backups, even if this function is done by the administrator group, or in this case, Hadley B. According to the webpage entitled Creating a Backup User, backups can be run automatically and the password is stored on the server, allowing it to be hijacked and putting patient data at risk. According to that same Creating Backup User article, one does not need to use insert or alter table privileges. The backup user is not going to be using that at all, but he will still need the ability to select the tables or view the data. The lock table privilege allows the table to be locked during the replication process so that no one writes while the backup is being created and no new data will be lost. These privileges are both on the database level. Since I want the user to have access to all of the database, I am using, again, that asterisk or wildcard to give this backup user group the same rights across all of the database. This maintenance user group will also need to have some global abilities across the tables. The replication statement including the ability to replicate and reload. The replication statement allows this user to copy the data from the main server to another or slave server. According to the article, Chapter 17 Replication, the backup can be run on a slave drive, allowing for there not be interruption to the main database during the replication process. In addition, the replication process can allow views to run on slaves and analytics, which will improve processing time on the main or master server. This process will be important as the project grows and as it increases beyond the 20 patients and 4 users. In this scenario, Nick P., who performs other functions in the facility, will only have one function with this DB_registry database or backing it up. After Nick P., the user is created, one needs to make sure that he has additional access. The maintenance role also needs to be able to run command prompt as an administrator in order to use the MySQL dump program. In the command prompt, Nick P., or the person running that maintenance role, will need to change the directory to where that MySQL dump program is. Therefore, Nick will need access to this part of the server. In addition, he will need access to this part, which is where where the file is kept. The next role that I created is the clerk role, who, as stated previously, cannot delete data but can view all the data in all the tables as well as insert and modify it. Graham has been assigned to this role. The last role is the view role. A view is a saved query that limits what can be seen to the columns and rows that are defined when the view is created. The view is an object that is saved as part of this database setup and is viewable only to those who have the appropriate access. The benefits of view including being able to restrict access to a database, since I'm able to include just the columns and rows I want a user or application to have access to. Again, creating that level of security and privacy. In addition, it saves complicated queries so that the user does not have to code the query to retrieve that view, and it can be replicated over and over. In this scenario, the user is Susan O, who is going to be using the database simply to follow up with patients and make sure they're up to date and compliant with testing, by using the view entitled need_follow-up_appointments. This view is going to be made up of only women over 40. The reason is that Murphy reports that although men and women both have increased risk of cardiovascular disease, women, the risk changes the onset of heart disease. Because estrogen generally is protected of the cardiovascular system, onset of heart disease in women is usually about 10 years after the average age. However, diabetic women are impacted at an earlier age, more on par with the age of onset in men. A nurse practitioner or another user like Susan O could look at only women of over 40 in this group and follow them more closely to make sure they're appropriately being followed for heart disease at an earlier age than the rest of the population. For example, looking at their A1C, last lab date, last eye exam, and make sure that they're on an ACE or ARB inhibitor for blood pressure. Or Susan O could create an educational program with this information designed for this high-risk population. She could contact these folks and could put together a program that would target modifiable risk factors that Murphy identifies, like abdominal fat, blood pressure, or stress level, to help lower those risk factors. As the project grows, more and more views can be created to help follow patients or create interventions to improve population. As you can see, we've created the role entitled view using the SQL code, creating a user and granting that view to Susan O. Moving to MySQL, we can take a peek at the workbench running the queries, and we can see that the admin has all privileges and that Hadley B has been granted that admin. You have the same for the backup, which is Nick P. He has the maintenance, and he has the reload replication, as well as the ability to select and lock tables on just the DB registry. You have the user clerk, which is Graham B, and he has clerk status. You have Susan O, who has the grant. And then finally, here is what the view is that Susan O has. Again, you have patient ID, patient contact information, their lab work date, A1C, last eye exam, and those are all of the people over 40. So those are the people that they would want to keep more of an eye on and make sure that these lab work, last eye exam, and all of these other are current. And it also has a column of their current age. Looking at my command prompt, you can see what Nick P, the backup person, would need to put in. Again, backing up just that DB registry to that file. And we can take a peek. And sure enough, there is the file right there, the 22620.sql. This pilot database is just the root and beginning, and it can grow to include more patients, more users in each of the categories, development of new roles, develop personalized interventions, monitor patient compliant, testing, and interventions. The way the database and roles are structured is such that you can expand what is monitored, adding different fields to monitor in each of those seven tables to be more comprehensive with the up-to-date studies. Thank you.